Hello everyone, welcome to AI Anytime channel. In today's video, we are going to work on a very interesting project. We are going to use a low-code AI tool called Teachable Machine to create an image classification model. So we'll build an image classifier basically for waste management. We will have multiple classes and we'll train the model using Teachable Machine, and then we'll take that model to create a Streamlit application, and where the user can upload some input images, the unseen images, and the model will predict or classify those classes that we are going to train on. So it has multiple classes that I will walk you through in a bit. And the reason that we are going to use Teachable Machine is that you would see that the demand of AI and machine learning has grown exponentially in the recent time, and of course for good reason. But not everybody has the understanding of the mathematical intuitions or the algorithms, or not everybody has the same coding expertise. So they need to start at some place, at somewhere, right? And that's where this kind of tool comes in. We have these low code, no code tools and platforms like H2O.ai, and there are other stacks as well, like Low from Microsoft, Teachable Machine from Google. And we are going to see how this tool can enable you or help you to kickstart something in AI and machine learning field. So we are going to create this image classifier. I will try to cover as much as possible on the explainability part, because it's mostly the black box. And once we train this model, we'll also build a Streamlit application, as I said, where we upload an image and it will classify the image in 3 to 4 classes that we have. And we'll also integrate GPT-3 model here to try to create some kind of awareness related to sustainability goals, like we have UN SDGs goals and how much carbon footprint a plastic bottle can have, or we have other classes, for example metal cans, glass, etc. So we are going to integrate large language models with this Streamlit application that we are going to build, and the model as well. So let's jump in. So you see, currently I am on Teachable Machine. So it says teachablemachine.withgoogle.com. So it is by Google, and their backend is on Google Cloud Platform. So if you see the interface, if you come here, you will see that they have in the left hand side a nav bar where you have some options like new project. So you can have your project. You can also open project from Drive. So if you have your Drive, if you're logged in with your Gmail, you can also link your Drive and open some project from there if you have some data sets, etc. And they have some details like how to gather samples and train your models. If you want to understand how this tool works, that I'm going to show you by the way. So if you see this, it says new project. Currently Teachable Machine provides you an option that you can work on 3 different type of tasks, or you can create these models. They have image project where you can create image classifiers. Then they have audio project where you can create audio classifiers. So if you want to classify different audios, now if you see, we have projects like COVID cough audio analysis. We are trying to find out from the cough sound, okay, if a person has COVID or not. Okay, we used to do that earlier in 2020 or 2021 or 2. And there are some other use cases as well that you can at least utilize this platform Teachable Machine to create some sort of classifier models for images and audio. Then they also have something called pose project. So they have pose classification where you have you want to teach your images, all the data that you have, what kind of poses people are doing. So you have victory sign, if you have thumbs up, thumbs down, different kind of poses that you can do. So and they also have something called more coming soon. So they are going to integrate more models here in the near future. But today we are going to look at image project. So when I click on image project, it gives me an option called new image project, standard image model, and embedded image model. So if you want to use something like Raspberry Pi, for example, you want to classify something through embedded devices like Raspberry or Arduino, you can also have a look at embedded image model, where you can create TF-Lite models, TensorFlow Lite models, for microcontrollers, and they have this input images of size, and you can work with them. So if you want to create models for those microcontrollers, you have to select this option. But in my case, I will go with standard image model, which works on these 224 cross 224 pixels of color images as an input, and then you can export that to your TensorFlow model or Keras H5 and TF-Lite or TensorFlow.JavaScript, TensorFlow.js if you are looking to build a web application completely running on the client side. and model size around 5 MB. You can see it's giving you some information about the output model size, and for embedded devices you can see it's half of MB here, 500 KB. So let's select standard image model. In this case, once I click on this, you can see an interface, very neat and clean interface. You can see they have multiple classes over here. They have something called training, and if you click on this, we'll cover that in a bit. And they have something called preview, where you can export model. You must train a model on the left, of course, and you can also add multiple classes. So the first thing I would like to walk you through the data set. So I have taken this data set, something called garbage classification. They have 6 classes, but I'm just going to consider 3 to 4 classes to keep it a little simple. And they have glass, metal, paper, plastic, and trash. You can read about this data set here. I will give the link in the description. You can read about this data set. They have metadata, etc. They have cardboard, glass, metal, paper, etc. Here you can read about this data set. And if you're coming over here, and we'll also use a tool called Netron. I will explain that why I'm going to use this tool. Okay. So if you come at this left hand side, you'll see that they have something called add image samples. They have 2 classes, class 1, class 2, and add image samples. So you can upload or add your data set, the data set that you have, either through webcam or through the file uploader. Now if you don't have any data set, if you want to try Teachable Machine, you can open your webcam and you can kind of capture 20 to 30 images or whatever images that you want to capture. You can capture through webcam, but I do have this image samples that I'm going to use. So let me just walk you through. So if you come on the garbage classification folder, you'll see I'm going to use these 4 classes. My classes are nothing but cardboard, glass, metal, and plastic. So if I open one of the folder here, you'll see I have something called plastic. These are all plastic images. So these are all plastic images. So these are all waste, guys, by the way. It will help you, build waste classifier. You build systems like waste classifier tool or waste classification app that will help you the entire, value chain or the entire chain of, where we are talking about the ecology or the environmental impact, right? It helps you mainly for waste management in ocean or anywhere else. So you can find multiple use cases around these data sets. Okay, so let's see how we can use Teachable Machine and GPT-3 to build a sustainability app to help create awareness to the people and the organization, of course. So if I click on this, I'll come back here. I'll click on this class 1. In this class 1, you have to name it. So let's rename this as cardboard, which is one of my class name from that folder. If you want to try something like other examples as well, like if you come on they also have trash, they also have paper, etc. So you can also name them. These are nothing but your labels. So my first label is cardboard, my second label is going to be plastic, for example, and I will also add new classes. So in new class, so cardboard, plastic, what are the others? So we have glass and metal. So let's add glass, and then I will add metal here. So this is going to be metal. That's it. All my classes are set. I will upload the data here. So I click on, you can see there are 2 options. Either you can get it from your drive. If you have data on drive, just import it from there, or you can just do it from directory. So I'll do it from directory. I'll come to desktop. I will go inside garbage classifier. In cardboard, I will click all the images. And you can see I'm uploading all my images over here, which is around 403 image samples of cardboard, all cropped to square as the instruction given over here. And let me just come down and show you a very neat and simple. I really like the interface of Teachable Machine, guys. So this is 403 image samples. Now what I'm going to do, I'm going to upload for plastic as well. So let's come back on this garbage classification. Let's upload the plastic. Make sure you have JPG or PNG images in your directory, and you can see 482 for plastic, 403, quite a balanced data. You should have balanced data, but if you we are not looking at accuracy here, guys. I will explain that why. We have to look at, we are building a classification model. It's a multi-class classifier. We have to look at other evaluation metrics. For example, we like to have something called confusion metrics. Okay, but if you are a seasoned data scientist, or if you hardly have any expertise in this area, and that's why we are using these tools, I will not bother about these evaluation metrics. what I want to show you in this video is that how you can create an image classifier based on your labels or the data that you have, how you can create a simple model, how you can use this in a Streamlit application, and how we can integrate GPT-3 to add on some values there. That's what I'm going to show you in this video, guys. So plastic is done. Now let's come back. We have glass. So in glass, I'm going to upload the data for glasses. I will go back on garbage classification. So in glass, you will see I will upload all these data samples, around 500 image samples for glass. And now the last one is metal, so let's upload for that as well. And from image, garbage classification, metal, and for the metal I will just say open as well. So I think metal has 410, so it's a good balanced data, guys, if you consider about all these 4 classes. So let's add a class, or will not add class for this, so you can also delete this. So let's delete class. And you can see our data is on the left hand side. We have uploaded our data, all around 400 to 500 data samples for each of the classes. And now the next step is something called training. So they have a button over here which if you click on this, it will start training. But let me explain some of the advanced feature. So if you click on the advanced, they have something called epochs, batch sizes, learning rate, etc. If you have no expertise, okay, if you don't know about these terminologies, they also have some high level info for you. One epoch means that each and every sample, so each and every image that we have uploaded in the training data set has been fed through the training model at least once. So we have epoch at 50. So if you see, if your epochs are set to 50, for example, which is true in this case, it means that model you are training will work through the entire training data set 50 times. So it will go through this entire samples 50 times to learn, okay, learn the patterns, learn the features. So there are terminologies like feature extraction when we are working with these deep learning models or even traditional machine learning models. So it will extract the features, learn the patterns inside it 50 times. It will go to all of the samples. Now if you have a look at something called batch size, so set of samples in one iteration. So you'll have, for example, let's say that we have 80 images and you choose a batch size of 16. So it divides in the batches, guys. So number of images that we have. So we have around 400, around 1700 images. If you have batch size of 16 here that we have, it will divide in the batches and then it will fed it to the model. Okay, so it cannot send it to the same time all the images. It will not learn, and also if you talk about the computational power there, okay, that's also a constraint. So we are dividing in the batches. So you can see 16 batch size. You can improve it to 32, 64 if you want. Just play around it. And then they have the learning rate. If you click on the learning rate, okay, and you can see I really like the message. It says be careful tweaking this number. Even small differences can have huge effects on how well your model learns. So I will not go more details into the learning rate. Okay, this is basically if you see the graph. Okay, I don't know if you're watching the video, if you're aware about the maxima or minima of this models when we are talking about gradient descent, etc. So learning rate is extremely important. If you are not getting a desired response, you think that your model is not learning well, if it's overfitting or underfitting, you can tweak all these values. For example, learning rate, you can increase and decrease to see how quickly it's learning, for example. So I'm not going to make any changes. Let's keep this as default. Once you click on the train model, what it will do, it will start training the model. It will take few minutes, and once the model is been trained, you will see on the right hand side this tab will be active. Okay, once the model when the model is trained complete. So let's start on this. Let's click on train model. So I clicked on train model and you will see some info messages over here. It says preparing training data. So it's preparing the data for you. Okay, so they need to perform some pre-processing steps before sending this data to the model. Okay, so the algorithms that you can see, it says page unresponsive. So click on wait. So you have to wait for it because it takes time. So let's wait for it. It will take little time. I will pause the video here and I will come back once the model gets trained completely. So you can see, guys, the model has been trained and now you can preview, and it says export model, which is one of the option, but I'm interested in this file, which click on the input on. And once you upload any file, for example, let's upload this file, and we are not testing it. So if you uploaded this file, it will give you the output over here. And for this image that you see, the test image, let me open that. This is one of my test image, and for this image you can see that I am getting this called plastic, which is the correct classification. Now if I upload, let's upload some other images as well. So I'm uploading this one of the test image which is not there in the training data set. The model hasn't seen this data. I have just downloaded this from internet. Now if you see this, it says cardboard for this one. Now if you click on other as well, for example, let's upload this we uploaded. Let's upload this. You can see metal, which is a Coke can, metal Coke can. Okay, so it's classifying accurately here, guys. So if you click on, for example, this one, okay, so cardboard. So now what we can do, we can download this model as well. So let's click on export model. Once you click on export model, so we can use this model later on. We can make some inference on top of this model. We can use this model to make classifications through an application, and that's why we need this model. Now if you see, they have three options here. The first is TensorFlow JS, the second is TensorFlow, and the third is TensorFlow Lite. Now if you want to create a web application through JavaScript completely on client side, if you want to run this model, you can use this as JavaScript as well. So you can have a look at this TensorFlow JS, which I am not interested in. And if you click on TensorFlow Lite, if you want to use the same model, on embedded devices or an Android mobile application through Flutter, etc., you can use this floating point quantized HTTP. These are nothing but to quantize or perform some pruning exercises to make the model weights lighter. So you can use this on embedded devices or smartphones or mobile devices. I'm interested in TensorFlow one. So they also have two options here. They have an option of Keras and shaped model. So what I will do, I will download this Keras model. So if you click on this download model, it will download a H5 format model. So I can use that model later on, and I can work with that. Okay. So you can say it says converting model. And in this case, guys, they also have given you a snippet, code snippet that you can use to make some kind of classification on your data. So if you create a Python file that I will show you, of course, in a bit. So let me first save this. So I'll just go on desktop, average classification. I will save this model. So you can see that I have a converted Keras zip. Once I click on this, it will have two files, hopefully. Once you click on extract, let's go inside this. You can see I have two files here. The first is Keras model H5, which contains your model weights, because we have trained a model to classify images, and that's what this file contains, the model weight. So you can use this to make classification on any images that you have. Of course, that should be relevant to the image that we have trained on. And on the labels, you can see we have 4 labels. It starts from 0, of course, as an index. We have cardboard, plastic, glass, and metal, and that's what we are going to do. So let me just cut this. And this is the interface, guys. So if you need saved model, you can click on saved model, TensorFlow saved model, and this is Keras that we have downloaded. You can have a look at the code snippet, and then we have TensorFlow Lite, TensorFlow JS. So this was the interface of Teachable Machine, where we have performed some drag and drop steps. We uploaded some kind of data, images data for 4 different classes. These are labels: cardboard, plastic, glass, metal. We went with the default configuration for training this model. So we trained it and we got a model. We exported that model in an H5 format. Now what we will do, guys, we'll create an Streamlit application that will take an input image, and then it will give you some information. The first information is of course going to be this result of the classifier, whether it's a cardboard, plastic, glass, or metal. And it will also have some information related to UN SDGs goal, and also the information about the possible or approximate carbon footprint that this kind of garbages generate. This is what we are going to do now, guys. So now let's build the Streamlit application, guys. So for building the Streamlit application, we need to install few libraries. to integrate this model in the web UI and also to integrate GPT-3, we are going to use DaVinci 3 from OpenAI through an OpenAI API keys, and we are going to create this. So for that, let me open my terminal, and in this terminal I'm going to open this in code. So when I click on the code, it will take me to this directory, and I can find out, if I just close this, if I come back to labels.txt, I will close all these files. This is my label.txt, which we got it from Teachable Machine. This is my folder, and in this folder, what I'm going to create, the first thing that we need is a requirements.txt. So for this, requirements.txt, and here we'll define our requirement. The first thing that we need is Streamlit, so let me just call it Streamlit. We also need something called TensorFlow CPU. We don't need a GPU machine here to work on this. It's pretty much straightforward. So we need Pillow as well to work with the images. Pillow, and we need NumPy for mathematical operation. When you install TensorFlow CPU, it also installs NumPy, but we will install NumPy as well separately. And then we need OpenAI, and we also need something called Python.env to handle the API keys, by the way. So .env, that's it. Python.env, OpenAI, NumPy, Pillow, TensorFlow CPU, Streamlit. So I'll go back to the terminal. I will create a virtual environment. So this is how we create a virtual environment in Windows. So VENV, if you want to install it through Anaconda as well, you can go ahead and create an environment in Anaconda or install it in base as well. So Python-m venv.venv, and I get a notification in VS Code that I have changed. There have been some changes in the directory. And now if you see it, I got a .venv folder created in this root directory. And now what I will do, I'll just go cd inside it. So cd.venv, and cd scripts on Windows. If you are on a Linux machine, you might have to go to cd bin. So cd script /activate in case of PowerShell, /activate to activate the virtual environment, and then I will do a couple of cd ... to go back to the root directory. So cd ... I will just do clear, again code. I do not have to go in the code one. Now I'll just install. So pip install, I will install all the requirements. So pip install requirements.txt here, by the way. So this will install all the dependencies, libraries, etc. that we need. So you can see it installing Streamlit 2, Python.env. Now let's head back to this VS Code, and I will create an app.py. So app.py, and in this app.py we'll write all our Python code. Okay, so, and we'll also take the code from the Teachable Machine. We'll just to make this little quick. So it's installing. Meanwhile, let me go back to this thing here, and I will go to my GitHub repository called AI Anytime. Once we go, I'll go to repositories. In this repositories, I'll find out some maybe this code. So I'll go back to this AI for non-tech. Sorry, what happened here? I clicked on that AI for non-tech, and in this non-tech, what I will do, I will take the code snippet. You can find out the link in the description for this repository. I just need the code basically for this Teachable Machine function. So I'll just copy this, which is of course the same as we saw on Teachable Machine as well. So you can see it's installing. Meanwhile, let me come back here, and I'll just paste. I'll just make a couple of changes. I will not call this function Teachable Machine classification. I will call this classify wastes, maybe classify wastes. This is my function name, classify waste, which take an image as an input parameter, because we have to pass an input image to use the model to classify between 4 classes that we have, or the 4 labels. And we have this model name, which is Keras model h5. Then we have labels.txt, rightly is okay. And then let me go back to imports. So for imports, we need this. Let me just paste it over here. So you can see these are the, and the same code was there available on Teachable Machine as well. When we imported it, you can also take it from there as well. But I will make some changes. I will come back to that. Let me just come back here from Keras models. Okay, this looks good. So if you see the import, we are using this load model module from keras.models, because we have to work with this model.h5 file to make the classification. And then we are using pillow for basic image operations. Then we have numpy for mathematical operations to converting to array, etc. And then we are importing Streamlit. By the way, if you don't know Streamlit is a web framework to build data science applications faster. That's what they say from their documentation. Now in this function, I'll explain that. I'm just returning class name and confidence code. I will return the function in bit. It's still installing. Let it install. And you can also see that I have an env file that I've created, .env, where I am keeping my OpenAI API keys. I cannot expose that at this moment in this video, so I am keeping that in safe in this env file, and I will use python.env to load the API key from there, and then I will do the prompt that I'm talking about. I'll show you in that bit. So now let's write the let's write the few code, but before, let's see if we install it successfully. It's still installing. Anyway, it's fine. Meanwhile, I want to cover something called netron.app, guys. So netron.app helps you to understand a little bit about the architecture or layers. It helps you visualize your architecture or hidden layers or whatever layers that you have in your neural networks. And for example, when we are working with Teachable Machine or completely low code, no code AI platforms, you are creating or training some models, it's very difficult to understand what kind of architecture these platforms or tools are have configured in their infrastructure to train those models. That's where Netron helps. So when you click on Netron, open model, let's open this model and try to see what kind of response we are getting. See, I have uploaded this keras .h5 model that I have. So you can see it's a sequential model. You can understand about the neural network arc here basically, and this is purely for your information. Okay, if you are interested, you can explore this tool. It's very powerful. We have some options here, so let's make it a little bigger so you can see this. So you say we have an input. We are passing this at 224, which is the input image as well. We saw on Teachable Machine. Then we have the input layer. You can read these node properties. Okay, you can find out the node properties here. It has input layer, TensorFlow modules has been used here, TensorFlow Keras, which is a high level API on top of TensorFlow. And then we have first one passing to sequential one input. We'll cover that as well. Okay, it's pass false, we have attributes, we have inputs, we have output. It helps you a bit about the explainability of your neural networks. So sometimes it's difficult to understand what kind of architecture has been used. So this helps you visualize. Let's don't keep it completely black box when you're working with Teachable Machine here. Now, if you click on sequential 1F, you can find it out all this here. So let me just go back to, again, let's make it a little bigger. Okay, and I will make this little bigger as well. If you click on sequential 1, again you can find out the same details on sequential 3, sequential, all the details are available here. If you click on the F, you can find out what are the pooling that has been used. You can see global average pooling 2D, so all the information. So if you want to also, if you click on this, you can also export this. So let me just go back here. So what I'm going to do now, click on this. Now if you want to export this as a PNG, go ahead and export. So I'm just going to keep this in the same garbage classifier, and I'll just keep this PNG file. Let's call this model visual or something. Model visual. I'm calling this model visual, and I just save this a PNG file. So if you click on the PNG file, you can see at least what are the layers that have been used. Is it a sequential model, or what kind of models that Teachable Machine is using. You can also export this as SVG, and I have all those details over here, zoom in, zoom out, etc. Okay, so I wanted to cover this tool called Netron. It's very useful tool. So you can also explore this. I will give the link of this tool in description. Now let's head back to terminal. You can see all of our libraries and dependencies are installed successfully. Now I'll go back on this VS Code here, and I will start writing code for my Streamlit application, guys. So how do we write a code for Streamlit application? So let's do that. So the first thing that I have to do, I'll just have an input image. So I'm just calling it input img, or let's have a title first. So for our app, we'll call this st.title. We have imported Streamlit as st, if you can see it over here, and then now we'll have ht.title. In this title I'm going to call it waste classifier. Let's call it something like waste classifier sustainability app. Okay, this is what I'm going to write here, guys. Okay, waste classifier sustainability app. And then what I'm also going to do, let's have a file uploader where we'll upload the input image. So in input img ht.fileuploader class, so I'm going to use this class. Okay, ht.fileuploader. It takes a label, so I'll give a label, enter your image here, enter your image, and we also have to handle the extension. So let's keep this in a list where we need JPEG, we need JPG and PNG. So this is what I'm going to do, PNG, and that's it. So input image, and now let's write this pretty standard Python code. If input image is not none, we are checking if there's a value, whether there's an image uploaded inside this. And here we can write our stuff here. So let's have a button called ht.button, Streamlit button. Pretty much straightforward, guys. If you're not aware about Streamlit, please go through the documentation. I'll give the link in the description. So if ht.button, let's call it classify. And in this classify, what we're going to do, if ht.button classify, of course this will be colon here, and if ht.button classify, and here we are going to, let's divide this, or let's do nothing here. Let's call it pass for now. I just did pass, and I will run this Streamlit application. How do we run Streamlit application is by this command, guys. Streamlit run and your file name. So my file name is nothing but app.py. So app.py, and when I click on app.py Streamlit, it will open a new tab in the browser having your app, and it will show something there. So let's wait for it. Let's also track this in terminal if you are getting some kind of error. You see we have no error. We have our title which says waste classifier sustainability app, looks good by the way. And then we have a file uploader, enter your image, where you can upload your image there. So if you click on this, it will upload an image and it will show you. If you currently see the layout of this UI, guys, I am not that satisfied, because I am not a person who likes container or container fluid. I want to utilize the full width of the app. So if you currently see, it's in the center of the app or the UI. I want to use the full width of this layout. So let's do that. How do we do that, guys? So it's pretty much straightforward. The first line of your Streamlit application should start with this if you're trying to personalize the layout. So I will just do set page config, and I have to use a parameter here called layout, which is white. Just do layout equals white. What it will do, it will, let's rerun. Once you rerun, it will take the full width now. It's taking all your width of the layout, and that's what I want. So waste classifier sustainability app, enter your image, drag, and now we can upload our image here. So that's what we are going to do. So let's handle the first column, guys. Okay, we haven't categorized in the column. Okay, so what we will do, you see we have this full width. Now let's divide this full width in 3 columns, okay, with equal distribution. So that how can we do that in Streamlit? It's very simple. So let's call this column 1, variable name at least, column 1, column 2, column 3, and here I'm going to call this ht.columns, and in I'm going to pass a list just to show you that how you can also give weightage when it comes to distribution of the columns. So I'm keeping it in equal 1:1:1. Give me equal width for all the columns. And now I will start writing code. So with column 1, what I have to do, let's just call ht.info by this case now, ht.info, and we'll have a status message, your uploaded image. That looks good. And in this, let's just show the image. So ht.image, our image variable input image, and a param. So param can be use column width. I want to use the entire column width. Let's call it true, guys, in this case. That's it, looks good. So let's come back, and also let me define column 3, 2, 3 at least for the naming convention here. So with column 2, and we'll call ht.info again here. Let's call this your result, something like this. Okay, for now let's call it your result. We'll see how we can change it later. We also have a column 3, so let's call this with column 3, ht.info, and information related to carbon footprint or carbon emission, something, something like this. Let's call it carbon emissions. And I'll go back to Streamlit application. I will do a rerun. I will click on this. Let's go to test. Inside test, I will upload this scan maybe. So let's click on classify, and when you see, now we are getting our result, guys. Looks good. So we have divided this entire layout in 3 columns, and in the first column we have our input image, which is a Coke can, my hero can, which is a metal, of course. We'll do the predictions there. It will classify. And then we have information related to carbon emissions and your result. Okay, this looks nice. Okay, now what we will do, guys, we'll use this Keras model.h5 to make the predictions that which class this image belongs to. So now let's come back, and it's pretty much straight. So what I'm going to do here in ht.info your result, very simple. I'll just have an image file variable, so image file, and in this image file we'll use image.open. So let's use image.open. If you see that we have imported this image from Pillow library. Okay, so we are going to use this image.open module, and in this image.open module we are going to pass input image, which contains our image. It's a variable, okay, that we have file uploaded over here, and in image file. Now if you run this complete code with the same function that Teachable Machine has given you, it might give you an error because image is a byte when you are using a Streamlit application. So if you're not if you don't want to save this in local directory, this image, guys, input image, so you don't have to use this particular line here which says image.open test png, which was given by Teachable Machine, or that I've taken from basically my GitHub repository. So what I'm going to do, I'm going to change this. We have to make some changes here. So what we will change, we'll just call image.convert. So we'll have an input image, you see, and in this input image we just have to do image.convert to RGB. If it's not, so that's it. That's the only change we have to make. Just make sure that this Keras model h5 and labels txt are same, and this looks nice. We are just using the same code. So if you see this, what we are doing in this function, we have image as an input parameter. We are loading the model and the labels. So we have load model. We are using this module from Keras models, and then we are taking care of the input size. That's how we pass it to our TensorFlow Keras model. 224, the standard size that we saw on Teachable Machine, and then the 1 and 3 for RGB, and then we're converting to RGB. If it's not an RGB, then we are defining the size, then we are converting to array, and that's why we're using NumPy, okay, because we have to pre-process the data to send it to the model for predictions, and that's what we are doing here, guys. And in running the inference, just looking at the maximum confidence score, and that's why we are using this function called argmax. So the reason we use argmax is because it's a multi-class classification, and we have multiple classes, and all these classes will have some sort of confidence score, and we only have to look at the maximum confidence score to classify the image. That's why we are using argmax function, and then we are just returning the class name and confidence score, and we'll use this here in image file wherever we are using on a Streamlit application. So let's do that, guys. So if you see image file, image open input image, now here we'll just define this. So let's call it label and confidence score, and label confidence score, and here we'll just use this function. So classify west, and I'm just passing this image file where I'm storing on top the previous line. So image underscore file, let's call this image file, and let's run this, guys, first. So what I'm going to just write ht.write to see what kind of a result we are getting, and then we make some changes on the UI. So ht.write confidence score, let's run this, and you can see I'm clicking on the classify button again. It's running it. If you come back here in the terminal, you will find your result over here, okay, and you got something, okay, you got 3 metal, which is correct response. So it's a metal, of course, and we got the result correctly with the confidence score of 99% for this particular class or label, whatever you name it, and this is correct. Now this doesn't look nice, so we have to handle this thing, guys. So how will we handle it? Let's see that. Okay, and let me just explain what we are going to do also here, guys, as I also discussed in the beginning of the video, and that's what the interesting thing about this video is. Now we have 4 different classes. Class 1, if I let me open that labels here, we have cardboard, we have plastic, we have glass, we have metal. Now all this belongs to one or the another UN SDGs goal. Okay, these are all garbages. We have cardboard based garbages, plastic based garbage waste, we have glass based waste or garbage, we have metal based. They all fall under one or the another UN SDGs goal. If you are not aware about UN SDGs goal, let me just show you what I'm talking about. UN SDGs goal. If you go to UN SDGs goal, okay, why I selected 3 here, let me just remove this. UN SDGs goal, UN has, the United Nations has 17 goals, okay, for the climate action that they are taking, right, for the climate change action that we have. And you see, from no poverty to zero hunger to end hunger, you know, to uplifting, then we have good health, ensure healthy lives, and all the individuals and organizations have to follow this UN SDGs goal. And this is what we are going to do in this video, in this column 2 that you see. So in column 2, if your class is metal, that will also, you know, publish this image. So in UI you will find those images there, you know, according to the classes that we have. So if metal, it will have all the UN SDGs goal picture there which belongs to metal based garbages or waste. This app helps you create awareness, to helps you create, you know, also to understand that this waste or garbages belongs to which UN SDGs goal. And this is what we are going to do here, guys. And if in this section, information related to carbon emissions, we are going to give some information or generate some information with help of GPT-3. If your class is metal, then what is the approximate carbon emissions, you know, in a year, or that we'll see how we are going to do the prompt. So let me open platform.openai, for example, maybe. So I'll just go here, I'll open this, I'll go to playground, and this is the playground just to get the prompt. But anyway, I will make the prompt. So you can ask this example, okay, which all UN SDG goals plastic based waste, you know, based waste fall. Okay, this is my prompt that I am making, just to, you know, upskill myself also, that okay, if I have a plastic based waste, this belongs to goal 12, goal 14, goal 15, goal 6, goal 13, etc., right? It belongs to responsible consumption and production. You have to look at the, we are talking about life below water, where you find abundance of plastic there, you know, in ocean, which is, you know, disturbing the entire life cycle of the ocean there, right? All the species we have. And then life on land also, you see the soil quality, etc. Then we have clean water, we have climate action. This is a plastic, guys. The same prompt can also be, you know, made for other classes that we have, metal, glass, etc. That I'm also going to make this prompt. So this is what we are going to do in this, guys. So I already have, you know, downloaded all these goals which belongs to these classes. You can see, and we'll try to show this, and you can also extend this. So we have 17 goals, but I'm just going to consider a few of the goals. You know, again, I took the help of, you know, OpenAI playground here to take this information and create this application. So let's do that as well right away. So what I'm going to do now here, guys, so, you know, with column 2, let's write this in column 2 only. So in column 2 we can create here, let's remove this, doesn't look nice, and here I will create 2 more columns inside this. So let's create 2 more columns. So if you see this app Streamlit column 2, let's divide this in 2 more columns. So let's do that. So inside column 2, I'm going to write column 4. You cannot give a same name, otherwise you will get an error. Column 4, column 5, I'm calling this. I'm just going to use st.columns again, and in this case I'm going to give 1:1 again. And here I will write with column 4. In column 4 I have to define the labels, guys. So with column 4, let's write this, okay, if label, or if, okay, let's do one thing. Let's not write like this, column 4, column 5, st column. Let's define this. And now first we have to handle the label, because if you click on labels txt, we have 0, 1, 2, 3. So let's handle this, because we cannot keep like this in our prompt. So for that we have to handle it. So what I'm going to do now, I'm just going to say if label equal, and the first will be, let's open this, we'll just copy from here, 0 cardboard. So let's copy this, and you also have to give a slash, backward slash there, because the next line is again a label. So let's give like this, 0 cardboard n, and yes. Now here what I'm going to do, I'm first going to write st.success, and let's write the success here. The image is classified as something like this. The image is classified as, so if 0, it should be cardboard, so let's call it capital, so cardboard. The image is classified as cardboard. This looks nice. And similarly, if that's a cardboard, so for cardboard we can also keep the UN SDGs goal, that you can also find out the playground. Let me just call it cardboard here, guys. So I'm just calling it cardboard based waste, something like this. Okay, I have to remove this. It will give me an error for stop action there in playground, and yeah, stop sequence, sorry. And now if you click on this, you can see it's giving me some 6, 12, 14 and 15 UN SDGs goal. So it has 6, which is about clean water sanitation, and then I have around 15 also, so which is life on land. So let's do that, guys. So this is classified at cardboard. So I'll now just write with column 4. Now here I will write with column 4, and we have to, so let's show 2 image in one column and the other 2 image, because most of the time we are getting 4 as we tested for plastic and cardboard. So with column 4, st.image, this is what I'm going to write, st.image, and I have those images downloaded in this SDGs gold folder, as I shown you, SDG goals. And so I'm just going to write SDG goals, and here I'm going to define the name for cardboard. So for cardboard, let's have, as we saw, 12, 13 and 15, so whatever. So 12 .png, and I'm going to use the column width again, so each column width true. Let me just copy this entire thing here. So I'm just copy this, and I will again paste it over here. So I just pasted it, so it's okay. I have just typed twice. So 12 for cardboard, and then we have 13 for cardboard, so this is 1. And in the column 5, with column 5, what I'm going to do, again the same thing, let's copy, and just I'm going to paste, and this looks nice. So we have 12, 13, 14, 15. Okay, so 14 and 15, that's it. Let's see if we are getting any changes here, guys. So if you click on, okay, that was for metal. So for cardboard we have written, let's upload a cardboard photo, guys. So I'll click on cardboard, and I will click on classify, and let's see if we are getting any error or what. So right now I will not get any error because we are not working with OpenAI, etc. So it's okay and perfect. So you can see we got our beautiful response here, guys. So for this case, waste classifier sustainability app that we are building, we have uploaded a cardboard image. Our model is working perfectly fine. We say the image is classified as cardboard, and we are getting this UN SDGs goals as well, and this will help you create awareness at your workplace. I mean, also if you are building some app, at a climate change action app, you can also build something like this. You can extend it further as well for all your other add-ons or features. So you can see for this it's working, but we have to do it for other labels as well. So let's do that. So I'll do it for other labels as well. So this is for one label, which is if label equals 0 cardboard. Now let's do that for other labels as well. So how we do that, guys? Let's just copy that. I don't want to do it for so we'll just have to copy from here. So let's copy this, and let's come over here. So we'll just paste this, and we'll just change the label. So this will be 1, and our 1 should be nothing but, what is 1? So we have plastic, so let's make it plastic. Make sure we're giving this /n here, plastic, and this, make these changes as plastic again here, guys. So plastic, and then for plastic, as we saw earlier, in the playground we have written, but I know for plastic. So for plastic, let's call it 612. So we have 6 JPG. So that's a JPG image. So let's call it JPG 612 and 612 and 1415. So this for plastic works. So similarly for plastic we did. Now let's do it for other labels as well, guys. So I'm just going to make paste again here just to save some time. So I'm going to make this 2, and in case of 2, what is this? So this is nothing but labels called glass. So we have glass. Let's put one more here quickly, and the last one is nothing but our 3, and that is nothing but the metal, guys. So that's metal. 3 is metal, and this will be metal here, guys. So let's call this metal, and this will be glass, and we have to make the changes in EU and SDGs goals as well. So for glass, what we have, I have noted it here. So for glass we have nothing but 12, 14. So for glass we only have one image in each column, so 12 and 14, it's okay. So 12, 14, and for metal we have 3, 6, 12, 14. So let's call it 3, and then 6. So 6, 3, 6, 12, 14. This looks nice. 12, 14. That's it. So this looks nice. Let me have a review. So we have 3 metal, 2 glass, 1 plastic, 0 cardboard. That's it. Now let's come back, and on our Streamlit application, let's put our metal back here, guys, and let's classify. So we have a Coca-Cola can here, which will get the prediction. It says we got some error here, guys. It says SDG goal 6 PNG. I don't know why we are getting this error, because it's not 6 PNG, it's JPEG. So it will be JPEG here. So let's make this JPEG, and this one, it's okay. Now let's hit this again, classify. When I click on classify this time, guys, hopefully we'll get our response, and this looks beautiful as well here, guys. So we have this input image, we have our classification from a deep learning model that we trained, of course, with a low code platform, a tool called Teachable Machine. Not a platform, I will say. This is not a platform at this moment. It's still a tool where you can, they have a drag and drop interface where you upload your data and train a simple model, very simple. And there were very much limitations on hyperparameter tuning, etc. That's not that advanced, but that works for you if you're just starting, and you're exploring this field of AI and machine learning. So if you see, we got our result. It says this SDGs goal for metal. Now the most interesting thing that is left now is information related to carbon emissions. Now information related to this class, okay, this metal class or plastic class, or other classes you have, we also need to do that, guys. So how will we do that? Okay, so for doing that we need to do a couple of steps here. So let's do that. Hopefully we have installed. Come back to requirement. We have OpenAI and python.enp, which is enough to work with this. So I will go back on top, and here I will define couple of libraries. I need OS first, so import OS, and then I need import OpenAI, and then what else we need, guys? We need something called from .env import that is load.env. So load.env, and that makes sense. So from .env import load.env, it's a constructor, so let's call this as load.env. Let's also define the OpenAI API key. So OpenAI dot API underscore key, pretty much self-explanatory. OS dot get env here, guys, and we'll pass the key. So key is nothing but the way you define this in your env file. So I have defined like this: OpenAI underscore API underscore key equal to your key, and it goes like this. Now this makes sense. So we have to write the function, guys. So let's write this function. So I'm writing this function here. So what I will do, I'll also copy that function from my previous videos or some GitHub repositories that I have. So let me go back to VS Code again, GitHub repository again. I'll go to AI anytime, I'll go to repository, and I will take any one of this. So let me take this food recipe generator using Whisper, which is open source model, and GPT-3. I will come here and I will take this code here, guys, this function I need, and come back. Let me explain this function to you. So I will remove this text to recipe here. I will call it generate, I'll call this generate carbon, maybe footprint info or something. So footprint info, this is what I'm going to do. And in this text, I don't have to pass text here, guys. I'm going to do label. So let me call this label here, and I will completely remove this prompt here, guys. I don't need this prompt for now. And here we have to make a change, because if you see the label, our label is like this, 0 cardboard ends. We cannot give this, we have to split this. So let us use a Python, basic Python there. So label equals label dot split. We'll use a split function of Python, label dot split, and in this label dot split we'll pass this. There will be a space, and here we'll use the first. Okay, this looks good. We only need this cardboard stuff that we are going to make the prompt. This looks good. We are going to use DaVinci 3, which is based on Instruct GPT, the most capable model. No, not now most capable model. We have GPT-4 as well. So this is not the most capable model. Earlier it was with GPT-3 and 3.5. Take DaVinci 3. I don't have access to GPT-4. I have to go with DaVinci 3 here, guys. Now let's make some changes in the prompt. So I'm just going to say, this is my prompt. So my prompt is nothing, but I have written the prompt. So what is the approximate carbon emission or carbon footprint generated from, and now here I'll give a space and I'll just give label, because that has to take from the predicted class that teachable machine model predict the class, whether it's a metal, whether it's a plastic. It has to pass here as a label. And then what I will do, I'm going to just do plus again. I'll give a question mark because that's a question, label. And here what I'm going to do, inside this question mark, I just need an approximate number, let's call it alt G, number to create awareness or something, create awareness, elaborate also in 100 words. This is what I'm going to do, guys. Elaborate in 100 words. I will give a comma here. This is my prompt. So I'm saying, okay, what is the approximate carbon emission or carbon footprint generated from label? I just need an approximate number here, guys, and to create awareness, elaborate in 100 words. This is what I'm going to do. You have a temperature to control randomness and creativity of your response. We have max tokens. My maximum token is 600. You can also reduce it. Let me reduce. Okay, keep it. We have frequency penalty, presence penalty, and top P. Okay, so you can watch my previous videos to understand about these terminologies if you are not aware. Now what I'm going to do in this case here, if column 3, so we have metal, and we are doing for this metal, etc. We have here, guys, if you come back here in column 3, so let's write in column 3. So in column 3 what I'm going to do, we have if here. So what I'm going to do, let's replace this. It will not be if, I forgot to make some changes. It will be else if. So let's call it elif and make this elif as well. And let's also have an else statement to handle the error maybe there. So in else I can say st.error. Let's call this st.error. The image is not classified as any relevant class, something like this. Okay, this is my, and now in column 3 we'll just pretty much simple. Let's call this a result, and in result I'm going to use that class. So generate carbon footprint in label, and can't pass the sorry, it was label here, so it only have the label. Yes, label. And then we're just going to do st.success, and in success we pass the result. So let's call this result. Let me have a recheck. So we have labels all defined correctly. We have this should work. So what I'm going to do now, guys, okay, I'm going to go back to Streamlit application, again hit a classifier, and let's see if we are getting any error there. So you can see we didn't get any error. Okay, we have our input image, we have our result of even SDGs goal, that in which SDGs goal this metal based waste or garbages fall in, which is good health and well-being, responsible consumption and production, clean water, life below water. Our prediction is here, the image is classified as metal, and the information is also using GPT-3. So it says the exact amount of carbon emission generated from metal. Focus on this label here, guys. So it's automatically taking the label as we have written the function. Metal production is difficult to calculate as it depends on variety of factors, which is true because we are not giving all the data, because calculating carbon emissions requires upstream and downstream information from data collection, defining boundaries, etc. So it's a complex task, but we are getting a value which will help you understand that how crucial this is now, to keep a check of climate change. Okay, everybody has to contribute. So you can read here, it says, however, the carbon footprint of metal production is estimated to be around 2.1 to 2.9 kg of CO2 equivalent per kg of metal. So if you have this cane, if you have multiple cans like this, not cane, we have multiple cans like this of metal cans. If it goes to 1 kg of metal, it generates 2.1 to 2.9 kg of CO2, which is a huge. This means that in order to produce 1 kg of metal, the equivalent of emitted into the atmosphere, this is significant amount of carbon emissions. Okay, so this is for metal, guys. Now if you let's upload this plastic water bottles here. Let's classify to see if it's working for all other classes as well. So you can see for this one, we got plastic. Okay, it's working very fine, guys. Okay, it's working perfectly. We have our SDGs goal, clean water and sanitation. You can see life on land, life below water, because so much of plastic inside ocean, you know it already. And you see this, the exact carbon footprint of plastic production is difficult, but again it's giving you some values there. 6 kilogram of CO2 equivalent. This was also working for plastic. Let's also try once more for cardboard, guys. Okay, if it works, we'll see. So we're trying for cardboard, and this is our last test. You can see it predicted as cardboard. It's giving us even SDGs goal, and we're also generating the carbon emission information, for based on this cardboard image that we have uploaded. So we got it. You can see the carbon footprint of cardboard is approximately 0.6 kg of CO2 per kilogram of cardboard. Just imagine if you have the kgs of cardboard. You have to look at the circular economy, how you can use this cardboard as in some recyclable way, if there is any possibilities to also contribute through circular economy as well, guys. So the entire agenda of of this video is to see how we can start with very less code. Okay, because most of the people I've seen, I'm talking right nowadays in the community, they don't want to write code. Okay, there are a lot of tools available. We are going towards API first world. We are going towards low code, no code. That's why I wanted to cover Teachable Machine. I wanted to use GPT-3, Streamlit. These are all low code or no code tools or platforms or APIs or models, large language models. We use DaVinci 3 here, guys. This was the agenda, how we can combine all these to to come up with a use case, come up with an interesting project or hobby project, and now you can scale this or extend this further at your workplace or as an individual project as well. So I think that's all for today's video, guys. Okay, this repository will be available, the code will be available on my GitHub repository. I will give in the link in the description. If you like the video, please hit the like button, and if you haven't subscribed the channel yet, do subscribe the channel. Please share the video and channel with your friends and to peer. Thank you so much for watching this video, guys. See you in the next one.